Express in simplest radical form. You know what? Actually, let's go over our divisibility rules. Probably in 5th grade, you probably went over what were called divisibility rules. And these are simply rules that allow you to quickly look at a number such as like 16 or 24 or 863 and kind of have an idea what it's going to divide by. So I'm going to give you probably the basics here. So the rules for 2 is that it's an even number. And when we say an even number, we simply mean that it's going to end in 0, 2, 4, 6, or 8. If it ends in any of those, by definition, it's even. Okay, so 3s is an easy one, but a lot of people forget this. So in short, we're going to add the digits, or add digits. And I'll give you an example what I mean by that. Add digits. Okay, so here is an example. If I had, for example, everybody knows that like 3 goes into 9 and 12, 15, etc. But if I had a bigger number, say like 123, this is kind of what we would do, is you would add the digits. So I'm going to go 1 plus 2 plus 3. And when I add the digits, the new number that I get, 1 plus 2 is 3, 3 plus 3 is 6. Now here's the deal. If 3 goes into the simplified number, and we all know that 3 does go into 6, that means that 3 will also go into 123. It doesn't tell us how many times. You'll have to do long division for that. But it does let us know, looking at it, that like, hey, we can divide by 3. We know it's going to work out. So just remember this. The 3's rule, add the digits. If the number that you get when it simplifies is divisible by 3, then so is the original number. All right, the other one you should have is 5s. And the rule for 5s is that it ends in 0 or 5. And then 10s is just as easy if it ends in 0. That's it. So if you know 2s, 3s, 5s, and 10s, you've got a good grounding. Now I will let you know that the rule for 6s, if you want, well, if 2 works and 3 works, 6 also works. But don't sweat that too much. Just make sure you know 2s is even, 3s you add the digits, 5 ends in a 0, 5 and 10 ends in a 0. So here's what we're going to do. We got 3-step process to solving the next 4 examples. 1, we're going to use a factor tree to break down the number under the radical. So I'm just going to go ahead and break this one down. I always like, if it's even, dividing it by 2 to start off. And then whenever I end up with a prime number, that one's not going to break down. That's just going to be a 2. 8 is going to break down as 2 and 4. I'm going to circle the 2. And then lastly, I'll break down that 4 as 2 and 2. So the number 16 completely breaks down to 2 times 2 times 2 times 2. Okay, so now after you factor it, what we're going to do is we're going to rewrite this symbol here. So I'm just going to draw the radical. I'm going to use a line, otherwise it gets a little bit sloppy for me. And so I'm going to draw my square root symbol, and then I'll put the bottom of each tree over these prime numbers. So I've got 2 multiplied by 2, multiplied by 2, multiplied by 2. And then I'm going to switch to blue, and I'm going to pull out as many pairs of numbers. So for example, I have a pair of 2s here, and those cross out, and then I'll put a 2 on the outside. And then I have another pair of 2s that's going to cross out, and I'll put 1 on the outside there. Now, so notice everything disappears on the outside, on the inside, and then on the outside we're left with 2 times 2. Step number 3, when possible, multiply outside numbers together and multiply inside numbers together. So there's nothing left on the inside, but on the outside I have 2 times 2, which is 4. But most of you probably knew that the square root of 16 was 4 already, but this is how you use a factor tree and then pull out pairs. All right, now we're going to go ahead and break down 20, something a little bit different. Again, if it's even, I always divide by 2. So I've got 2 and 10. 10 will break down as 2 and 5, and 2 and 5 are both prime, so that ended pretty quick. So I'm going to draw the square root symbol, trying to keep things organized here. And then I'm going to write all the prime factors of 2 times 2 times 5. I'm going to pull out as many pairs as possible. So it looks like I have a pair of 2's here. So I'm going to cross that out and put 1, 2 on the outside. And then when possible, multiply the outside numbers together and multiply the inside numbers together. Well, in this example, it's pretty easy. There's just the number 2 on the outside, and there's just the number 5 left on the inside. So the square root of 20 simplifies to 2 square root 5. Fourth one, and this one's going to be a little bit long. So again, 64 is even, so I'm going to divide by 2, and that's going to give me 32. Again, I'm going to keep dividing by 2's as long as it's even, because that's easy for me. So I'm going to do 2 and 16. 16 will also be 2 again, and that's 2 and 8. 8 is even again, so that's going to be 2 and 4. Again, always circle your primes. And then 4 is going to break down as 2 and 2. So it looks like we just got a whole lot of 2's. So I'm going to go ahead and draw the square root symbol. And I'm going to put as many 2's as I can here. I've got 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, and 6. And we're going to pull out as many pairs. Okay, so I've got a pair of 2's here, gone. Put 1, 2 on the outside. I've got another pair of 2's, gone. And then it looks like I have a third 2 that will also come out. So it's simplified on the outside as 2 times 2, which is 4, and then 4 times 2, which is 8. So I have 8. And then notice everything underneath the radical simplified. So the square root of 64 is 8. All right, let's try one more. Let's do 96, and then we'll call it quits. Now again, you probably know I'm going to divide by 2's, but I do want to just give you a quick reminder that this, if we add the digits 9 and 6, 9 and 6 simplifies to 15. Does 3 go into 15? And the answer is yes. So eventually when we're done, there's going to be a factor of 3 in here. Again, I just wanted to show you that 9 plus 6 is 15. 3 goes into 15, so 3 will also go into 96. But I'm going to stick with my tried and true dividing by 2's. So I'm going to go ahead and do 2 times 48. 2 is prime. 48 is 2 and 24. Again, 2 is prime. 24, as you probably guessed, is going to be 2 and 12. And notice I keep getting lots of 2's. 12 is going to be 2 and 6. And then finally we get our 3, because 6 is made up of 2 multiplied by 3. Let's take all the primes and put it underneath the radical. And I'm just going to move it over here. I got a little bit more room here. Okay, so I've got 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5, and then it looks like I have a lone or solitary 3. Switching over to blue, I'm going to pull out pairs. Again, step number 2 is always to pull out pairs. So I've got a 2 on the outside. Don't forget to cross them off. I have another 2 on the outside. And I'd like to pull something out of here, but it's a 2 and a 3, and those are not pairs. So now when we get to step number 3, when possible, multiply outside numbers together. So on the outside, 2 times 2 is 4, and multiply inside numbers together. So on the inside, it's 2 times 3. So that's going to simplify to 4 root 6. And there you have it. Please let me know if you need any help.